Good morning, I am Srilekha, Department of Chemistry. Today we are going to talk about on the topics of electron potential. So here, the electron potential, how the electrons can be developed by using the voltage and the current transfers into the solutions. So here, when the metal M goes into the solution, any one of the following reactions can be occur. So whether the metal M, that is the metal M, when goes into the solution, will react with Mn plus. That is, it forms as a metal ions with the loss of electrons, Ne minus. So this is the formation when the metal M goes into the solution and it forms as a metal ion and with the liberation of the electrons. And then the same process with the cathode. It is a cathode which is a gain of electrons that we can accept as when the metal M plus Ne minus which gives M. So here the product is M. Whenever the product M metal gets to this oxidation reduction of electrons, whether it is in the form of solutions. So here the electron potential can be derived with this formula of when the substitution for this reaction is when the zinc electrode is dipped in zinc sulfate solution, the electrode drop is dipped in the zinc sulfate. So here the zinc when goes into the solution as Zn ion in the form of a metal ion with the liberation of electrons. So here the oxidation process is occurring in this process, and when the electrons can attain the negative charges due to the accumulation of valence electron. So here the electrons attains the valence electron, and due to this valence electron, the ions of the solutions gets attracted by due to the negative charges, and the remaining the positive ions remains close to the metal, and it forms as a positive and the negative layer with the formation. So here when the zinc electrode is dipped in zinc sulfate reaction, the oxidation process takes place and the metals loses their electron from the Zn to Zn2 plus ion. So here the electrode attains the negative charges due to the accumulation of valence electron. So by getting this accumulation or attraction of the electrons, the positive ions is attracted by the negative ions in the solution, and it remains close to the metal. So this is the process how the zinc react with the zinc sulfate solution with the loss of electrons. And with this next one, the copper. The copper, which is nothing but copper is an oxidation reduction process. It can attain a gain of electrons. So the electrons can be gained by using copper with copper sulfate solution. So the copper, the solution dipped in the copper sulfate solution. So the copper gets immersed, can be deposited over the metal, and it attains a positive charges due to the accumulation of valence electron. So by using this accumulation of valence electron, the positive charges can be attracted by the solution in the negative charges. So the positive and the negative charges remains from the metal, and it attains the gain of electrons. So due to this, the zinc and the copper electrodes can be oxidation or reduction. Both the process can be carried out by using this in the electrode potential, and these solutions can be carried out by using the metal M with this metal ions with the loss of electron, and from the gain of electrons to the remaining to form a metal. So this is the process how the electrode potential with the positive and the negative layer, both the combination with oxidation and the reduction is called as an Helmholtz electrical double layer. So the process of combining with the Helmholtz electrical double layer is nothing but the metal to a metal ions and with the loss of electrons, and with the gaining of electrons with the copper to copper sulfate solution. So both the oxidation and the reduction process is carried out in these reactions, and we will get this following by using loss of electrons and the gain of electrons. So whenever the electrons can be gaining or loss of electrons, we do by using this potential, and developed by using this positive and the negative terminals. So however, the electrons can be shared by using this zinc with the zinc sulfate and copper with this copper sulfate. It can be used by the transfer of electrons. So the transfer of electrons by using the Helmholtz electrical double layer, and the applications later to this electron potential is how the electrons is sharing the positive and the negative, and thus potential developed by using this positive wave to middle to the negative terminal. Whenever we have this electron potential is distributed by the formation of negative to positive, these applications can be carried out in the electrode potential. Thank you.